Hello everyone, welcome to the last session of Vulkanised 2019, the panel discussion about exploring both the challenges and opportunities of cross-platform GPU standardization. My name is Alon Orbach, I'm from Samsung. We'll have brief introductions of our wonderful panelists. The point of this session is now become a traditional feature of Vulkanised, is to have a bit of an organised discussion that tends into a Q&A/opinion being shouted at from the floor. I'm going to start off with Jan Harold on my right. Jan Harold Fredriksson is the lead architect for media software at ARM, looking at GPU and API co-developments. He has represented ARM and Kronos since 2010. It's been 9 years. God,
yeah, I know.
It's flown by, and has been involved with Vulkan from its inception. Next up, Hans Christian Artsen, from which, as we heard earlier today, heads up Spear v. Cross. Hans Christian is an independent developer and leads projects like Spear v. Cross and also Fossilize. There's been quite interesting blogs on that recently that he's put up. He previously worked at ARM, hacking on the Mali GPUs with Vulkan in particular. Next, Alex Smith from Feral. Alex is a graphics developer at Feral Interactive, working on Linux and Android ports of AAA game titles, and he's led the development of Vulkan support in most of Feral's Linux releases over the last few years. And finally, Lou Kramer, like my best German pronunciation, is a developer technology engineer at AMD, who just spoke at the last talk in the game engineering group. And her job is to work with developers and help their games look beautiful and run fast on AMD CPUs and GPUs. So welcome to you all. Finally, myself, Alon Orbach, I'm part of the game ecosystem team at Samsung, which is part of the overall Galaxy game dev. And we work together with game developers, make their life as best as possible on our flagship mobile devices and make Android and Vulkan even more awesome. So, I would like to attempt to, as well as kind of look at how things have gone, also try and look at what we can do from our experience of Vulkan, 3 years old now, where its direction is. And it is true to say that everything is awesome. However, we have learned that some things are more awesome than others, I think is the correct way to phrase this, which is what I'd like to explore today. But to start off, let's start off with a positive, just to ease us in. And wanted to ask the panel, starting with you, Jan Harold, what feature in Vulkan are you most fond of and why?
I'm not sure feature as such.
Aspect.
Yes, aspect is better. So I think the CPU load side of it I'm pretty happy with. So I guess we tried to do different things. So one was, to make a API that was a bit more transparent, and so you sort of had less driver magic going on, which would then make drivers run, require less CPU cycles to do their work. And I think that part of it has worked out quite well. I'm not sure the drivers necessarily got super simple. They still have some complexity to deal with, but they do require less CPU cycles, which leaves more goodness for everything else on the system.
How about yourself, Christian?
It's kind of a weird feature to be my favorite, but actually having persistently mapped memory is it's my favorite feature of Vulkan. Because, before, in the old days of GL, before you had, well, if you're lucky to have a good GL 4.5 implementation, that's like one in the world. Then you can have ARB storage buffer, that's basically in core Vulkan. And just being able to map memory persistently, hammer that, it's visible by the GPU, either by host memory or directly to the GPU if you're unified architecture, and just not having to deal with the issues of you have to map a buffer and then unmap it and all the stupid API overhead you get from that alone, and just being able to make your own scratch allocator for uniform buffers alone is like, it's my favorite feature. Being able to do that in
100% standard core, no fuss. It just works.
Alex.
Alex.
Yeah, I think
Yeah, I think I'd basically echo some of those points as well, because like the CPU performance of Vulkan has been like one of the major benefits for us over GL, and also the predictability of the performances, because like going back to when we've been working on GL, you have like things you've got profiling and stuff. Don't know why we can't see it, see what it's doing, but then go to it, it's like it's doing what you tell it. You know exactly what it's going to be doing. You know when it's going to be stalling to do certain things. It's just much more know what's going on. It's really good benefit for us.
Lou, do you concur?
Yeah, kind of. I mean, I like Vulkan because it's so explicit, and actually when I started to do graphics programming, I started basically with Vulkan. I did a bit of DirectX 11 before, but it was quite obscure and I never really understood what was happening. And when I started to program Vulkan, I actually also understood the GPU better because of this, and that's what I really appreciate. Yeah.
Before we delve into a couple of points raised there, can I just see an indication of how alive the room is? Who might be jumping in with a question or a point of opinion at some point during the next hour? This is not committing fact. Just want to get an indication if there's anyone with something just on the tip of their tongue. Okay, a few hands. Okay, this is good. But just in terms of one of the key philosophies we try to bind ourselves by is the idea of no driver magic. I'm definitely sensing the pressure to kind of maybe there should be a bit of driver magic coming in. Do you think that's something you hear either in the driver teams or in dev tech, or do you want more driver magic as a developer? Were we right, and is that still holding tight?
Sure, right. So I think we were right, but I also see that pressure coming. And so far, I think mostly avoided. But the pressure is, so for us as a driver developer, the pressure comes when, oh, suddenly there's an important title out there that maybe it does something stupid, and please make it go faster. You go, no, come to, we're not supposed to do that. We're not supposed to do driver magic. And I think have held up so far on that particular front because while Vulkan is intended to be explicit, it also makes it really, really hard to do driver magic. So if it was easier to do, we may have been more tempted by now.
Anything you'd like to have off your hands and being done back in the driver?
Maybe like if there's, wouldn't want anything that's like huge amounts of driver magic that's going to be just the driver doing tons of stuff behind your back. That's going back to the thing of you can't predict what the driver is doing. But if it's just here and there you can do, that's not gonna it's not gonna hurt us or anything. Fine with that. Just saying like driver is doing.
Yeah, I think the biggest magic thing we're seeing now is like the frame buffer compression thing, which is like we're supposed to have this explicit API, but all the vendors have a completely different idea of what compression is, and there the driver magic comes in, because often there's a case where, yeah, it works in 99% of cases, but that 1% case, well, it's explicit and you can't just do things at the last minute in Vulkan and a driver. It's like, yeah, just disable it. And that's a case where, let's say, you're using a legacy API and it might end up performing way better just because of the explicit drivers force drivers to be very slow anyway. Or not slow, but they end up running slow on the GPU just because you can't deal with that 1% case. Yeah, I'm kind of seeing the issue from both sides, both trying to hack on the driver and then trying to make applications run on drivers. I think one of the biggest issues is that Vulkan can support things that makes things extremely difficult for the driver to do optimally. Like just having the fact that you have aliasing, memory aliasing, which can be super useful, but it also means the driver has to like, no, I can't do anything now. That's annoying. And I kind of wish there was, from the beginning, way to say, okay, this resource can never be aliased by any magic, or just do your thing, basically. But that's impossible in some cases, some drivers, which is frustrating. There are cases where the explicit nature actually hurts performance in weird edge cases.
Yeah, you touched on quite a few of those with DCC.
Yeah, I mean, but like my experience with working with game devs is that they're kind of keen to understand what the driver is doing, and also understand why the driver is doing certain things related to the hardware. And if I explain the reasoning, usually they also understand, and they're not really asking for driver magic, because I mean there are reasons why the driver has to do it this way. So yeah, that's usually really understandable in this case.
Yeah. So for the kind of thing like frame buffer compression, I think it would help if like developers gave more the IHV gave more details, like as you did, about what specific conditions you get a frame buffer driver and that kind of thing, for all kinds of like where an IHV wants you to get the best performance in there. IHVs can actually have like best guides, but this is what I kind of need to do. So like that information you have yourself.
That was a hand-waving interjection there.
That was, you can finish if you want. But,
No, don't finish. It's fine.
I was just gonna say that I agree with John that as the vendor right now with Vulkan, we can't really fix your performance, and we also can't really fix your application. Which means that if you, as a developer, if you don't respect the spec, and oftentimes you don't use the validation layers, then we can't help you. Or at least we should not help you.
You wanted this.
Yeah, so I think. No, sorry.
No.
I was going to say, I think there's like things like validation errors, like if you're shipping validation errors. I think there's like, because Vulkan, like there's a spec that do all the things you can do with the API, but not all of that is necessarily going to be best practice for a given IHV, because it's like you can set whatever flags on your image you like, that disable DCC or whatever like that. So it's like there's nothing. Look at the spec and say, oh, I can do this, but some vendor their driver might really dislike doing that, and it's going to put you on a slow path. So it's like there needs to be more kind of information that tells you what is going to be giving you the best performance.
So how are things going with PerfDoc?
That's me.
That wasn't answering it. That was okay. Yeah, save the PerfDoc for. Yes.
Take the pressure off. It's more a question, I guess, for Alex mostly. You mentioned that maybe it's not obvious where the paths and stuff are, but one of the things I remember from the bad old days of GL is having about 50 ways to do like data upload and stuff like that. Is it, yes, it's true that I think I agree that we could give more feedback to developers about what's going where in general. But is it better than you've had before?
Yeah, for sure. Yeah, like the buffer upload thing is like however many ways to do that in GL, and each different driver has their own path. So yeah, like we ship stuff on GL, it's like use this path on that driver, use this path on that driver, like 4 different buffer upload paths for different drivers.
There's a reason I mentioned persistent buffer.
Yeah, so that's great Vulkan. Like, yeah, for sure there's less things like that, but say for example, command buffer and descriptor. Certain ways you can do that perform certain drives compared to others. It's that kind of thing. But it's, for sure it's better GM.
So one plug for something we're trying to do in the Vulkan working group is it's a gallant effort. It's going to be seeing how it goes, but to try and provide cross-vendor best practice guides. So based on actual features, rather than having to go trawl through 7 or more PDF documents and find the right section and so on, is to actually have single documents, and that's something that Chris as our DevRel lead is leading on. It'd be great, by the way, just to ensure it happens, do speak to your favorite GPU vendor and encourage them to support this effort. Just as a show of hands, do people think that's a useful thing, or do you think you're happy with having GPU specific, so architecture specific documents? Can I get an indication for interest in such an effort? And skeptics? Thank you, Tobias. I think that it's definitely a challenging. Sorry, you were chipping in.
This information about what the driver can or can't do, like, oh, now I can't enable DCC. Why can't it be?
And that is why I mentioned perfdoc, and Wasim was looking at me happily. Perfdoc is a layer that is trying to provide performance, so not things which are incorrect in the API, but good performance guidance.
Yes, I wasn't going to say anything. We've got a version 1.1 plan. Hopefully we can add some of the things we got on the roadmap. Not sure if we can do things like that, but for AFPC, for example, we can give some guidance whether you get it or not.
And are you welcoming contributions to
Absolutely.
that?
GitHub, so any contributions welcome.
And are you getting contributions from other GPU vendors?
Not yet.
So I think that's an example of an effort, and it's still weird. We're 3 years old, but still early days to try and get some.
Yeah, I think this just really just a question of, do you have a Kronos Vulkan layer or like Kronos group / performance stuff, or is it the case where we want every IHV to create their own little layer, or do we want a joint project, like kind of like Luna G validation layer, except it's for performance?
Yeah, and there's areas where they contradict. You can think of quite a few where there's only a single vendor that recommends something. And others disagree. So that part of the challenge is for us to actually form those, whether it's as a layer or in documents, or actually how do you combine all those contradicting bits of guidance?
Yeah, I guess, so I think some things can be captured that way, like probably the compression, maybe at least a lot of the compression stuff, like the things you had on the slide could be captured there and actually matches pretty much one-to-one with what we would recommend. But I think we did find when we did RenderDoc back in the day, there are other things that are tricky to extract from the driver, and I guess Lou also mentioned some things are like GPU card specific, and it's hard to get them, to replicate all that stuff in a different layer, and then you have to worry about the layer and your driver getting out of sync. So some things are probably better to get as feedback from the drivers directly rather than trying to bake them in.
Yeah, I think the primary case where this is really hard can be stuff like multipass, where it's like, okay, you want a few subpass, but does it though? And kind of want to query it, but